Hello everyone, and once again I welcome you all to the course on kinematics and theory of machine. So in this lecture we'll be discussing basically about the cam and follower, its classification and all. Okay, so in the previous lectures we have already discussed about the cam, how we can define them, we have seen why it is used, how this particular cam works, so some of the application areas and all. Okay, so now today we'll be discussing about the different classification of cams as well as followers based on various attributes. Okay, so in the last previous lecture, if you can recall, we have seen that this cam, it's a kind of the, can say, just like the input. Okay, it's and the follower, we get the output motion. So almost always the cam is the driver and the follower is the driven, and the motion of the follower is mainly dependent on the shape of the cam. Okay, so and we have seen that basically it has got this cam and follower combination. It has got three basic elements: the cam, the follower, and the frame, which acts as the support for the assembly, as well as it guides the whatever is the motion of the follower that is there. And different you can say mass scale production of cams, it is generally done by, we know that's, but like punching press, die casting, or different milling methods. Okay, so today we will be discussing basically about the classification of cams. So this cams, they can be divided according to its shape. We can also divide it in based on how the follower is moving, and as the on the basis of manner of constant of the follower. So now in the based of shape, how can we classify the cam? So based on it, it can be classified like radial or disc cam. So already we have whatever cam we have considered for demonstration purpose, so there we have actually considered the disc cam or the radial cam. So also we have cylindrical cam, we have the end cam, we can also have a wedge or flat cam, wedge and flat cam, we have spiral cam and conjugate cam as the different classification based on shape. So as you can see from this particular uh, figure, so here you can see one of the type of, we are just showing different types of, you can say, cams and all, cam and follower mechanism. So here this is the cam. Okay, this is rotating about this particular uh, axis. Okay, the green part is nothing but through that, actually the axis is there, and one follower, the red part we are showing, and this particular is a kind of follower. Similarly here also the gray part is the cam. Okay, and it is rotating about this point. Okay, this the axis. Okay, through this particular point basically the axis is moving, and this is the type of follower. So here we are showing two different types of followers also, and in this particular figure we are basically showing how we get the maximum and the minimum leg in case of the follower movement. So okay, so in this figure what we have seen, as we already know, the motion of the follower basically it depends upon the shape of the cam. So you can see that whenever this particular, if this is rotating, this is a rotating cam, so this is also is a rotating cam. But here you can see this cam is, we can also have translation motion in the case of the cam. Okay, and basically the motion that the follower is getting, it is basically governed by the shape of the cam and how it is basically moving. Okay, so here in this particular figure we are showing the different types of any kind of different shapes we can have in the cam. Okay, based on that we are going to get a particular type of definite motion on the follower. Now in this particular case, all of you can very easily see. Okay, so as the cam is rotating, so we know that cam and follower, they are always in constant contact. We want that the contact should be there. Okay, we don't want that the contact is broken, should be broken in between the cam and follower. In that particular case, transmission of motion will not will never happen to the follower, and if that is not happening, ultimately we are not getting any output motion. So the contact of the cam and follower, it should be constant contact should be made. Okay, it should be. So now in that particular case, all of you can very easily see. So depending on this particular position or particular position of the surface which is in contact with that particular follower at a particular time, so based on that the follower is getting the motion. Whenever it is this particular, suppose initially if it is like this. Okay, next if it is during the rotation, if the position is something like this, so in that particular case we have seen that we can see If suppose initially it is like this and follower position is like this, and suppose this is the center. So in the next case, if it has rise to some other location and all, okay, so based on that, suppose the follower location will be somewhat different, so the follower is showing this kind of movement here. Similarly, this there definitely in case of this, generally a guide is given, so guide we have to show along this direction, so it is constrained. Okay, the movement is constrained along this direction. Similarly, here you can see it's a eccentric cam that we are showing. So here one thing you must remember is, even though the look of the cam, okay, it is somewhat circular, but you can see the center of rotation, that is the axis position, is not exactly at the geometrical center of this circle. So if that happens, if the axis of rotation is here, then what will happen, even if it rotates, the cam rotates continuously, then also the position of the follower, which will be here, will not change, because what will happen in that particular case, so this way it will keep on rotating, and actually it will be, if the center is at if the axis of rotation is exactly at the geometrical center of the circular cam, so in that particular case the distance for all the positions from that particular point will be same, and so if the follower is here, it will remain there even if the cam keeps on rotating. But as you can see in this particular case, as actually the follower center is the cam center is, or axis of rotation of cam is here, so what will happen, sometimes it will be in this, it look will be somewhat like this, and sometimes we will also have a position when it will be something like this, also we will have a position when it will be like this. Okay, also we have this particular position, also we will have this particular position, also we will have this particular position, and all depending on this particular center. So based on that particular, whatever be the location, what will happen, sometimes it will be here when this is at this position, but whenever it is at this position, so the cam will fall to this. Similarly, whenever it goes to the extreme below position, it will again move like this. Once again, when it keeps on rotating, though, it will rise. So it will fall, the follower will fall, and then it will rise, and thus this kind of reciprocal movement it will get. Okay, so circular cam, shape of the cam is circular, but actually it is, they are eccentric cam, because the center of rotation is not exactly at the geometrical center. Okay, so similarly in this case you can see, so the follower movement, it may be translation type. Okay, as you can see here, it may be also oscillating. So here you can see, if the cam in this particular position, that is green point, actually it is pin joint or pivoted. So in this particular case, because of the rotation of the cam, what is basically happening, the follower is getting this kind of oscillation motion. So this is oscillating follower. Similarly, we can also have translation motion on the cam. So once again, here you can see the cam is translating, and actually due to the shape, this kind of shape which is given on the cam, so because of that, as the follower is in constant contact with the cam, so based on the shape of the cam, actually the follower is either moving down or it is moving up. Okay, so ultimately this kind of motion in a time wise fashion, based on whatever be the shape, as well as whatever is the this particular speed, okay, translation speed, so this particular motion you are getting. So similar is the way, if you want something else kind of motion, so based on that you have to derive the or design that particular cam profile, the look of the cam. Okay, similar here we are just showing that different types of shapes are possible in the case of cam. So that's all. And similarly here we are showing that in this cam, in the shape of if the shape of this particular cam is something like this, so basically whatever be the movement, that is a stroke movement of this particular follower, that we use the word this lift word. Okay, that is the stroke or going up or down, that particular word we use the lift, forward lift, how much actually it is moving up. So in this particular case, as this is the center, so from here whenever this point is in contact, so this is the maximum lift position. Okay, similarly you can see the minimum lift position. Okay, so next, as we are saying that there may be based on shape, we can have radial, we can have cylindrical, etc. So those things in details we are going to discuss. So what are these radial cams? So in radial cams, what basically happen, the follower reciprocates or oscillates, both the things are possible, in a direction which is perpendicular to the cam axis. So this is the not you can say definition for your radial cam. Okay, so as you can see here, the follower is reciprocating like in this particular direction, and the cam is moving in this direction about this particular axis. And now this particular axis, in which direction actually it is there, so it is like this. Okay, like this means actually it is inside, it is going inside the this particular you can say this particular page you can consider. Okay, so what happens, so if you look from this particular view, so the follower is moving up and down in this particular guide, cam is rotating. Okay, the cam is rotating like in this direction, and because of the shape of this cam, whenever this point is coming in contact, then it is moving up. Whenever this particular portion, the constant radius portion, is in contact, so there is no movement on the follower. Similarly, when it once again it reaches this particular portion, slowly it moves up and it goes down, and there is some, at certain point there is no movement at all. So this kind of complicated motion can be very easily generated by this cam and profile. Okay, cam and follower profile. So here what happens, you can see axis of movement of the or the follower is rotating or oscillating in this direction, and basically this white portion, which is actually showing the sub portion, okay, it is actually going from this view inside the page. Okay, so these two direction is kind of perpendicular. Okay, so these are radial cam or disc cam. So similarly in this figure, in the four figures, we are actually showing four different types of followers. Okay, so later on we'll discuss, like here you can see the shape is kind of those things we'll discuss while we'll be discussing about the follower classification. Similarly, we can have cylindrical cams. So as you can see, in cylindrical cams, the follower either reciprocates or oscillates in a direction which is parallel to the cam axis. So in this case, the cam axis is like this, right? It is rotating like this. So in that particular case, as you can see, some groove is being cut on the cam surface, and this cam joint is it is there here. Okay, and this part of the follower actually it is connected with this, so this portion is connected to this particular follower. And due to this arrangement, what is basically happening, depending on what is the contour that is made on the groove, okay, so the way it is moving, so as this portion is always inserted in this groove, so basically while it is moving, so whatever be the portion of this particular groove that comes in contact, whatever be the you can say shape, okay, if it is like this, or sometimes this portion will be in contact, sometimes this portion will be in contact and all. Okay, so based on this follower will move in this particular direction. As you can see, this direction of movement of the follower is parallel to the axis of the cam. So these are cylindrical cams. Okay, and they are called as positive type, because you can be sure that whenever the follower moves, cam moves, there will always be some movement on the follower, because in the groove of the whatever is being cut on this particular cylinder, okay, as you can see this kind of group and all, so based on that always it will be in contact with it. So here it is being shown that actually it is in this particular direction it is going, and similarly if we pivot it, it can have oscillation motion. Similarly, we can have end cam, so which is also sometimes included within cylindrical cam. So what basically cam 7 is somewhat similar to cylindrical cam, but now the contact of the follower, it is at the periphery of the cam. So you can very easily see, so this green portion is nothing but the follower, this blue is nothing but the cam. Okay, and you can say it is kind of somewhat cylindrical, but what is basically is here, so actually this face, front face, upper face, you can see there actually some contour is given. So based on whatever is the type of contour that has been given to this particular cam, okay, so actually the follower will be somewhere here. So depending on at which portion the follower is in contact, so the follower will be either moving up or down. Okay, and here as you can very easily see, the end of the cylinder is the working surface, not this particular side, you know. Okay, in the previous case on the surface the groove was cut. Okay, now this end portion is the working surface. Okay, so these are end cam. Similarly, we can have wedge and flat cam. As you can see, the shape of the flat cams are kind of wedge shape. Okay, and after that, just like in the previous case we have discussed, generally they can have this kind of motion and all, and based on whatever be the working surface, based on this shape, actually it is having this particular movement. Similarly, sometimes it can also, we can pivot here and it will be oscillating. Similarly, the other ways movement also is somewhat possible. Okay, so in this particular case, km is of wedge shape. Okay, here also it is positive drive is achieved without using spree in case of flat cam which groove, as we have seen in the previous case. Okay, just like in the cylindrical cam, if we provide some flat cam with, this is flat cam, so here it can move like this. Okay, flat cam with some groove if we provide, then we can be sure that whenever there is movement on the cam, we can expect positive drive on the follower. That means follower will always move, so that is positive drive. Okay, but in the other cases, generally to maintain the, we know that cam and follower, they should be in constant contact. So in this particular case, it is, you can see like some spring force is given. Okay, we are using some spring so as to maintain this particular contact and all. Okay, as well as to give the positive displacement to the follower. Similarly, in both the cases of wedge cam as well as flat cam, so cam has translational motion. Also, we can have spiral cam, as from the figure it is evident. So here a groove is cut in the form of a spiral. This is the spiral groove. Okay, the spiral groove, it consists of teeth which is in mesh with a pin gear, and that pin gear is the nothing but the follower. It acts as the follower. So this groove where some teeth are being cut, spiral teeth, so that will be, the follower will have a pin gear follower. Okay, it will be mesh with it, and velocity of the follower, it is proportional to the radial distance of the groove from the axis of the cam. Okay, so there's some other type of cams like conjugate cam, two cams etc. there, globoidal cams, spherical cam etc. You can just go through it from any books. Okay, try to explore what are the differences, how they look like, how they work. Okay, once you have understood this thing, other portions you will definitely be able to understand. Okay, next we'll be talking about the cam classification based on follower movement. That means what type of movement the follower is showing, whether it is going up or going down or whatever. Based on that, we can have different classification of the cam. So based on this, we can categorize like RRR, that is rise, return, rise. So which one is the rise stroke? Rise stroke is the stroke in which the follower moves up. Return stroke is the stroke where follower falls or moves down. Okay, so now, so in all those cases, basically we discussed about the movement of the follower by considering, suppose if the cam is having rotational motion. Okay, like that, and rotational motion means once complete revolution we discuss about. Okay, that is 360 degree. If we know the behavior of the follower in the complete revolution of a cam, then in the next revolution once again it will be, behavior will be somewhat similar, so it will be multiplied with whatever is the 360 degrees based on whatever be the number of cycles that you want. Okay, but if we know about the behavior for 360 degree, that is one cycle, that's enough for us. So there is a diagram that we which we draw to show the behavior of follower displacement with respect to the angular movement of this particular cam. So this kind of diagram is known as the displacement diagram. Okay, so in the displacement diagram, in the x-axis we show the cam angular deviation or rotation, in the y we show the follower displacement. Okay, so because we are interested in basically at a particular, when the cam is moving, what is the position of this particular follower, or how much displacement is there in the follower, that is what is our interest. Yes, and when it is at which position of the cam it is there, so that is of our interest. So displacement diagram shows that. Okay, how the follower is having the displacement or having the movement during a revolution of this particular cam. Okay, so based on that, later on we'll discuss there are different strokes, rise stroke, return stroke, etc. So in the rise stroke, the follower moves up based on the shape of this particular cam and all, and in the return stroke the follower moves down. And as you have seen from the previous, some of the previous examples, sometimes the cam remains stationary. Okay, so there is understroke known as the dwell. Okay, so what happens in the dwell? So dwell is a time, or the dwell is a stroke when basically the cam is having continuous movement. Okay, so the cam is rotating but the follower remains stationary. There is no movement or no displacement on the follower. So that portion is known as the dwell. And generally, how can we obtain dwell? So basically, whenever the surface that is in contact, or the point in contact with the cavern follower, actually if whenever it encounters the constant radius curvature, so basically in that portion, in that particular angle, so there will not be any change in the displacement of the follower. So the cam will be rotating, but the stem follower will remain stationary. There will not be any extra displacement. So if we consider, suppose for this particular cam, suppose if this is the shape, okay, so we can see that if this is the center, okay, so for this angle, for this particular angle, it is constant radius for this theta. Okay, here it is changing, the radius is changing from this point. Okay, so in this particular case, if the cam is rotating, suppose in this direction, so from this point to this point, okay, whenever there is the contact of the follower with this portion, so what is happening, even though this cam is rotating, so the for this particular angle, as this is the constant radius, so there is no change in the distance for this particular point, so the follower will remain here. After that, depending on which portion is coming in contact, so after that, suppose it may so happen that this will be like this. So happen sometimes what may happen, I'm just showing the different possibilities. Suppose this is the shape and this is the center, so whenever it is rotating in this direction, okay, it is rotating like this, so there may be some portion when it will look like this, there will be one time when it will be in this position, similarly there will be time when it will be in this position, yes, there will be time when it will be in this position, there will be time when it will be something like this. So depending on that, if suppose initially the follower was here, so when it reaches this portion, okay, then what will happen, the follower will be, it will come down to this portion, the constant contact is there. Whenever it is here in this portion, okay, the follower will still come down, it is coming down. So this is basically, and whenever it is lowermost position, actually it will reach the lowermost position. So this is sweep stroke, this is the fall or return stroke. Okay, next, when one after that it is in this direction, so once again now the follower will be position will be something like this, yes, up to this portion. Okay, similarly when it is here in this, the follower will move up, it is now moving up to this location. Okay, actually this lateral difference will not be there, it will be this position only. Okay, and whenever it is once again moving this, so it will move up to this much, so it will be rise, it will rise up. So similarly after that, moving down also. Okay, so this kind of thing will happen. So this is the rise stroke, return stroke, and dual stroke is the stroke when the cam is having movement, the follower is not having any movement. So based on that, we can have RRR, rise return rise. We may start even from dual, then rise return dual. We can also have dual rise dual return dual, etc., and dual rise dual. So similar these cases, this can be shown in the, this can be shown like this. Okay, so in the displacement diagram, so it is moving up, that is rise, okay, and there is return. After that it is 360 degrees over, so once again rise return, or like that. Similarly, this is dual, we are start from dual. So dual is the period when there is no movement on the follower, no displacement. Wherever previously the follower position is there, there itself it will remain. So if we start from zero, starting from zero, there is dual. So dual during this portion there is no movement. So it is dual. After that it is rise, it is going up, there again once again it is dual. So now the position of the follower is here. Now during this dual it will remain here, there will not be any other displacement, it is neither going up nor down. So after that once again it will fall, it is return stroke, and like that. Similarly we may start from dual, then rise, then directly we can have return, and so on. Okay, similarly what is fall, this is the fall where suddenly it is moving down. In the other cases it is return, it was taking some time, some angle of rotation or time, ultimately for rotating that much angle some time will be required. So it was like that, but now it is directly like this. Okay, Similarly, based on the follower constant, we can also classify the cams. So how can we classify the cams? We can classify like preloaded spring cam, where the contact is ensured by preloaded compression spring. We can also have positive drive cam, where the constant touch between the cam and follower is maintained by a roller follower operating in the group of a cam, just like we have discussed in the case of cylindrical follower, cylindrical cam, as well as flat cam with some groove cut. Similarly, we can have gravity cam, where the rise is achieved by the spring surface, rising surface of the cam, and returned by the force of the gravity. That means due to the self weight, it moves down. Okay, so those are the classes. Similarly, we can classify the followers based on also shape, movement, and location of the line of movement. So already about shape and movement you already know. So classification of follower according to shape. So this is mainly based on the shape of the point which is in contact with the cam surface. So they can be classified as, we can have knife edge follower, where you can see this is the follower, these are the followers. So this edge, it looks like a knife edge, so that's why it is known as knife edge follower. Similarly, we can have sometimes a roller at the end of it which is in contact with the cam, so those are known as the roller follower. Similarly, we can have mushroom follower. Under mushroom follower, we can have flat face follower. We can also have spherical faced follower, as you can see from this two diagram. So based on that particular shape, they can be classified. So now out of them, basically knife edge follower, its use is limited, because you already know, as the cam and follower, they are in contact, always the constant contact is there, and some relative motion also is there, rotational motion. The cam is rotating, the surface of the cam and follower is in contact. So if we are talking about the knife edge follower, so the wear and tear is of the surface is more, that's why its use is limited. And because of that, to eliminate this kind of problem, so this roller follower, which is mostly a cylindrical roller, which is with a center at the pin joint at center. Okay, so that kind of roller follower, cylindrical roller, which is free to rotate about a pin joint, this kind of roller follower is used. Okay, but it's widely used, but sometimes what happens, in the case of steep rise, if the rise stroke is very steep, that has been given to the say the cam, so in this case the full roller follower, it may jam the cam, so it is not that much preferred in case of that kind of situation. So this kind of problems, it can be overcome by using suppose some flat face follower or spherical face follower, which comes under mushroom follower. So this jamming problem is now not here, but high surface stress and wear is there due to the deflection or sometimes misalignment in case of this flat faced one, that is the number C. But this problem can be reduced if we go for this spherical faced follower. Okay, so these are the classifications follower based on the shape. Okay, the shape is with the point of contact with the cam surface. Similarly, we can have reciprocating follower and oscillating follower based on the classic movement. So as we have already discussed, as the cam rotates, as you can see from, it is the similar kind of figure that we have previously used. So as here the cam rotates, so the follower reciprocates in the guides. We have to show the guides. Similarly, during, based on this particular pin, so based on this configuration, here the follower is oscillating about this particular pin or the hinge. Okay, so this, if this kind of case is there, then this kind of situation we can consider oscillating follower. Similarly, according to the location of line of movement, we can consider like radial follower or inline follower. Okay, so it is also known as inline, in the same line, that means inline follower. Okay, so it's also known as inline follower. And we can have offset. You already know the word offset. So now, what is radial? How can we define them? So in case of radial follower, here the line of movement of the follower, it passes to the center of the cam. So what is the center of the cam? Here this is the center of the cam. Okay, and this is the line of movement, axis of movement of this follower movement. Okay, axis of follower movement, and this particular center of this particular cam, they actually coincide. Okay, so if that is happening, this kind of situation, it is radial follower. Okay, so it's not required that for being a radial follower it has to be like flat face follower also. So, but the situation is, if even if it looks like this, if you can consider suppose a knife edge follower, then also as it is moving, passing through this particular center of the rotation of the cam, so it will become a radial follower or inline, in the same line. Okay, and what is offset follower? It is just a reverse, when the center of rotation or the line of movement of the follower it doesn't pass through the center of rotation of the cam, or if there is a distance, you can say, as can be seen from this figure. So this is the line of movement or axis of movement of the follower, and basically this portion is nothing but the center of the cam. So you can see there is a distance between them, offset distance E can denote. So if that kind of situation is there, so this arrangement is known as offset arrangement of cam and follower. Okay, and this follower is offset follower. Okay, so this is basically about in this class. So in the next class we'll be discussing, next lecture we'll be discussing about the different nomenclatures of cam profile. Okay, thank you.